Hello, welcome to another 3D printer review, but this time a little bit special because this is Ender 7, a coreXY 3D printer, which is advertised as a fast printer which is able to print up to 250 millimeters per second. And this box is sent to me by Creality 3D shop in exchange for a review. But let's go step by step. My name is Igor and you are watching my tech fan. Specifications of this printer: the printing volume is 250 by 250 in XY direction and 300 millimeters in Z direction. It used the linear rail for linear motion, well, at least in XY direction. It used the high power motors, stronger part cooling, it has full metal dual gear extruder, so from these parameters I can see it is optimized for speed. The bed temperature can be heated up to 100 degrees Celsius, and according to specifications, the nozzle up to 260 degrees Celsius. Now, this is the only parameter which I can see it is not really optimized for speed, because for higher speed we have to raise the temperature, and okay, for PLA we have enough space to raise the temperature, but for the PTG or ABS, not really. I'm not even sure that it can be heated up to 260 degrees Celsius safely, because I'm not sure yet, but if this printer used that classic Creality's hot end where the bottom tube goes down touching a nozzle, in that case it's not really recommended to go above 240 degrees Celsius for a longer period, because Teflon may result some toxic fumes and it's not really good for the longer period of time. I'm just curious if Creality moves to some kind of all metal hot end. They're not much expensive. Probably they have good reason for this. I don't know. If somebody knows, please let me in a comment. Okay, now let's talk a little bit about theory. What makes coreXY printers so fast? Here we have two stepper motors responsible for moving in XY direction. Similar, like with the Ender 5 Pro, which is cubic frame Cartesian, but with this we have stepper motors which are responsible only for moving in one coordinate. For example, this stepper motor moves the hot end in Y direction. This stepper motor moves the hot end in X direction. With the coreXY, if you want to have motion in only in X direction, in that case two stepper motor has to work together. They some kind of split the work. But with diagonal movement, only one stepper motor is working. So if diagonal moving, theoretically we would have advantage on this cubic frame Cartesian. So that's not the reason. Of course, in this case, one of the reasons is that on Ender 5 it's moving with these V-slot wheels, and on Ender 7 we have the linear rails. But I believe the main reason is this stepper motor here. As you can see, it is on moving part, and we are placing a lot of moment of inertia in this movement. And with the coreXY, two stepper motors are static; they are not moving. And in that case, we don't have limitation of the size. We can have heavier, bigger stepper motors, as we already have. I already mentioned with the Ender 7. But also there is one disadvantage of coreXY system. If you take a look, this timing belt, how long is this? It's long, this length, but double. Same on the y-axis. With coreXY we have much longer timing belts. But believe it or not, the timing belts are elastic. Not much, but if the timing belt is longer, like on coreXY 3D printer, in that case, with the same load in millimeters, we will have a bigger prolongation of the timing belt. This means it must be very good quality, and also the setting must be extremely precise. It must be tight, but not over tight. So with the Cartesian printers we have more space for errors, but here that setting must be good to get good quality printing. But that's enough for theory. Let's see what's in the box. I will need more space on the desk. User manual. Sample filaments, again on the spool, that's what I appreciate. Half kilograms of PLA plus. Power cable. Some bolts. memory card with USB adapter, zip ties, Allen keys, pliers, wrench for the nozzle, spool holder, spatula for removing the printed object. This is the top frame of the printer with the hot end. Some alloy extrusion, probably vertical alloy extrusion. Another vertical alloy extrusion. And alloy extrusion with the least screw inside, so probably this moves the Z-axis. Some parts for spool holder and some kind of plastic cover, not sure. This is the printing surface, and you can see how pre-assembled it is. And it is supported on one side, but here we have these supports, which I am missing. That's one of the first updates which usually owners of the Ender 5 prints. And this is the base of the printer, and it's really heavy. And the box is empty. I want to assemble as soon as possible this top frame because I'm not happy that it is on its side, but I don't want to place it on this filament runout sensor or stepper motors. It is quite pre-assembled, so I will just follow these instructions. For this step I will need the base, the Z-axis component, the washer, and M5x18 bolts. Now, this is first time I can see that the type of the bolts is printed on the bag. It's a little bit hard to see, especially if we have these black bolts. So these are what I need. But as you can see, it's quite pre-assembled, so these are all the bolts or screws which I have in the package. First I have to take out these cables. And now the Z-axis component. And now only 4 bolts screwed from the top, so it's good because we don't have to turn upside down the base of the printer. And according to the manual, only on this right back hole I have to use this lock washer. I'm not really sure what's the reason, but let's do it. So in Z direction, the linear motion is guided with these V-slot wheels, and it is a good opportunity to check the tension on these eccentric nuts, which are on the back side of this printer. And this process is same like with other V-slot wheels. So on the front we have fixed wheels, on the back side we have these eccentric nuts, and as you can see I can rotate this wheel with my hand very easily, so it's not tight. I will use the open-end wrench and rotate this eccentric nut until I cannot move the wheel with my hand. Now I cannot rotate them, for example in opposite direction, or if I hold this one. And just to check, the motion is still smooth, but not over tight, so it's ready now. The printing surface will be mounted here, but let's talk about this bolt here. The height of this screw is adjustable with this nut, and it will press the Z-axis limit switch. Next step is installing the Z-axis profiles. There are 2 of them, and they look equal, so there is no left and right side, and they are symmetric. Only thing I notice here that there is a bolt in the middle which stands out, so this has to go up. And I have to screw 4 bolts on one side using the same screws as with the previous profile. Next step, installing the printing platform, and for this I will need these smaller M4x6 bolts and 8 of them. Here I have to take off this first protection foil to access to those holes where I have to use the bolts. First 8 bolts into these horizontal holes. After tightening 8 bolts into these horizontal holes, we have 4 more, which are vertical holes. So I have 2 holes here and same from the other side. This Allen key was provided with the printer, but it is very useful if you have this kind with this ball ending. In that case you can use this Allen key under a small angle. And now mounting the top frame or top component, and this side where the stepper motors are goes back. Only I noticed I have to be careful not to pinch the cable here because it's on the way for the limit switch. Now it's a little bit hard to see, but again only one lock washer has to be used, and it is on the right back side. It's very hard, there is a small spot, I hope it's visible to the camera. And that's exactly the opposite hole where we already used this lock washer, only now here on an upper hole. Just one more time, quick check that I didn't pinch the cable between these two parts. And if everything is okay, then I can continue. And after tightening the screws on back extrusion, I can continue on 2 extrusions which are on the side. And for 4 bolts I have to screw in from the bottom. And same on the other side. And now mounting the filament holder. For this I will use these 2 smaller bolts. So here is the extruder, and there are 2 holes for mounting the spool holder. And now the Z-axis cover, so these 2 parts goes into these holes, and you have to snap these parts here. And now the cable connection, I will start with this bigger one, it goes up here. And I have these clips to secure this cable to this hollow extrusion. One more for the middle. The next one is the Z-axis motor cable. Next is the heated bed cable. And I can secure it with this nut. And before you plug the power cable and turn it on, it is extremely important to check if the voltage is set correctly for your country. And since I live in Europe, so to me it is now 230 volts. If you live in the US, then you have to switch it to be here 115 volts. Now mechanically it's assembled. Let's remove this protection foil. Let's take a closer look. So here is the power switch and the place for the power cable, the spool holder. There is a filament runout sensor and that metal extruder. And through this potent tube, it goes here in the hot end. So there is the stepper motor for the extruder, and those are stepper motors for the coreXY mechanism. And this is the hot end, and what I can see here, it has 2 part cooling fans directly here, so definitely yes, the part cooling is much better because it's from two sides and also both sides has its own fan. And yes, it is above the style, so this is very light, this head, so it can move faster because it has less moment of inertia. Here on the left side there is a hole for the USB cable and for the SD card. The leveling is manual but assisted manual bed leveling, I will show you later, and as you can see it has those stronger yellow springs. They are completely compressed now, so I hope for the first homing the nozzle will not hit the bed surface because it will be stopped by the limit switch. And now let's turn it on for the first time. It has 9 languages, English, okay. Let's analyze a little bit better this display, which is very sensitive. I really like it. So with the printing, I can start the print, but I will do it later. Here on the temperature, I can start probably preheat automatic PLA or ABS, or manually I can set the temperatures. And I really like that I can enter some number here, and I don't have to press the arrows up and down until I enter the number. Okay, cool. Fan disable and settings. In settings here I will do soon the bed leveling, or I can unload the filament. Here I can do the movements. I can set the size of the step, and then this is the button for the homing, or I can enter directly the coordinate where I want to head to be moved. Here I can change the language, motor control, probably I can turn on and off the steppers if I want to move it manually. And this is the printer info. You can see here the firmware for the display and the printing size. I think it's time to remove the protection foil. What I can already now mention that I can hear fans, so it is not quiet machine. Now we have additional cooling fan here on the hot end. And I noticed I am missing a sticker here, so probably I have to print something, or maybe just cut this part off like the 3D printing nerd did. And now the first homing. And it did the homing in X and Y direction, and now it is lifting up the bed, and I hope it will stop before the nozzle hits the bed. But just in case, I'm holding my finger on the switch. Okay. It stopped now. I have approximately 5 or 6 millimeters space. This plastic really blocks the view. It's very hard. On it there is a small gap where I can see the nozzle to set the bed leveling or anything. But I wouldn't recommend to cut it completely. Maybe I will also drill some holes here. But this structure, I believe, must be rigid, so don't cut completely this frame here. I can see approximately 5-6 millimeters between nozzle and the printing surface, and I believe it's too much because I don't want to use the tension on the spring so much, so I have to move a little bit the bolt which press the limit switch. Not too comfortable for operating, so I want to lower this bolt approximately 2 or 3 millimeters. And then I can lock the position with this nut below it, which also has the tension with the spring. Probably it's not visible on camera. And now the distance between nozzle and the top surface is 2 millimeters. And now I can start with the bed leveling, because now if I rotate those knobs, I will still have some tension on those springs. So let's do the leveling, and as I mentioned, it is assisted bed leveling. This means that, look at this, it has auto leveling, which is off now. Maybe this firmware is preset to mount the BL touch, maybe, and then it can do it automatically. I don't know. And aux leveling, I think this is some kind of assisted manual leveling, and it's doing the homing now. And after the homing, I have to use some paper sheet and to place it between the bed surface and the nozzle. And then by pressing one of these buttons, it will move above that knob. So I will start with number 2. And now I'm rotating the knob until I get that friction between nozzle and the paper. And then next point. Again rotating the knob until I set that friction. Next point. And the last one. And one quick check in the center. And sometimes you have to repeat this procedure several times. Nice vacuum packaging, and also there is a silica gel inside. End of the filament is locked with these stick tapes. Cut the end of the filament under 45-degree angle. Through the filament runout sensor. Then through the extruder. It's a little bit hard to work with this printer. Definitely it's hard for camera too, but also for operating. For example, to remove some filament from the end of the nozzle or similar. This frame is really on the way. For the first print, I recommend to print some G-code which is on SD card. In that case, if there is any problems, you know that it is not caused by the slicer, because this G-code is prepared by the manufacturer. Print, not the choice. And during the printing, we can adjust the fan, printing speed in percentage, nozzle temperature, bed temperature. And the fan, again, I cannot see setting the percentage only on and off, and the Z offset. It's starting with the homing, and now it will start with the printing. The printing started fine, but this was 4 hours printing. So manufacturers, please always include some G-code which can be printed in half hours, like a badge or something like that, because new users want to have their first prints as soon as possible. And pay attention to the infill lines. They are horizontal and vertical. I'm not sure is it visible on the camera too, because this movement is advantage for coreXY, because in that case 2 stepper motors are working together. That's quite big overhang, and the printer is handling it quite good thanks to those 2 part cooling fans. That's very impressive, especially with this speed. And it's finished. The bed temperature is 48 degrees Celsius. Let me check the bed adhesion. It's still good, okay. I will wait completely the bed surface to cool down, and then I will remove it. Printing surface now cooled down to 25 degrees Celsius. Oh, and it's completely detached. Let's see the skirt. That too. Let's analyze it a little bit. Or it's quite heavy. Let's see the weight. 117 grams approximately. And let's check the size, because I saw there is the STL file of this bunny on the SD card, and I want to scale it up to see what is the estimated time if I would print it on Prusa printer, for example. And size of this bunny is 129 millimeters approximately. And the quality of this bunny is great. Almost I can see no vertical lines, maybe this one here a little bit under the shadow. But the overhang, this quite big overhang came out perfectly the ears too. The bottom layer looks very nice, this texture like the glass on the printing surface. And of course only here I can see that ending of the top surface. I inserted this bunny into Prusa slicer and I scaled it up proportionally to get the 129mm height. And I use 0.50mm speed profile. I'm not sure, but I guess some similar profile was used on that printed bunny. And in this case, it would need 8 hours for the printing. And I can see it would even use less filaments, only 105 grams. Now it's time to see what's on the SD card and to prepare the Cura for the slicing and to print some own object. So this is the content of the SD card. Here we can see the user manual in PDF, but the content is similar like the version which is printed. Software and driver. So here we have an installation for the Creality slicer. Since it is a modified Cura, I rather use the latest version of the Ultimaker Cura, and I will add the Ender 7 there. Troubleshooting, again, some PDF with instructions, models. Here we have that STL file for those two G codes we can find in the root, and this is the root, so these two files can be found here. And the last one is the operation video, so the installation, how can you assemble this video. So maybe you don't even need mine. I will add new printer, add a non-network printer, and I already checked, unfortunately the Ender 7 is not in this list. So you just add a custom FFF printer. I'll name it here Ender 7. Add. And I will change here the printer settings, 250 by 250 millimeters, 300 in Z direction. It has the heated bed. And on this page I will change nothing else except here on extruder it is 1.75 millimeters is the diameter of the filament. Adding a Benchy as an STL file, and I will play with the settings. 0.2 millimeters layer height. I use here the generic PLA profile, and the difference from the different values you can see now on the screen. The printing speed is 250 millimeters per second almost everywhere except on the first and last layers. The retraction I left 5 millimeters, nozzle bed temperature 220 by 65 degrees Celsius, and minimum layer time 1 second. Everything else, as I mentioned, is default. These are not perfect settings, just my first settings to print my first object, which is the Benchy. I try to rotate the lines of the infill because horizontal or vertical lines are better for coreXY because two stepper motors are working together, as I mentioned earlier. Unfortunately, I couldn't figure out myself. If somebody knows how to do it, please write me in the comment. Estimated printing time by Cura was approximately 31 minutes. Unfortunately, Cura didn't count with the acceleration time, because to get that speed of 250 millimeters per second, the nozzle needs some time, similar with the cars, and with a smaller object it's almost finished the movement until they reach that speed. %90 of the bench is finished, and 15 minutes. I'm not sure will it be less than 1 hour. Oh, it's done, and printing time 55 minutes. And I think it's hot. Let's try to remove it to see the adhesion. Oh, it's good. Great. Okay, I cannot remove it with my hand. Okay, I will wait to surface to cool down, and then let's analyze this Benchy. The printing surface is cooled down to 25 degrees Celsius. And yes, completely detached, so it's very easy to remove the Benchy. One string I can see inside. Overhang is quite good. Here I can see some lines along the Z-axis. Here too. But not bad, Benchy. Even the chimney came out quite good. I was thinking that there will be a problem for the short printing time for the layer. Let's analyze the temperatures a little bit with this thermal camera. The base temperature is maybe 34-35 degrees Celsius. Here the all electronic is placed and the main board, so that's not much. Let's try to catch the stepper motors for coreXY mechanism, those two spots behind. Let's see if I can isolate them. (54) and the other one 55 degrees Celsius temperature of the stepper motors, which are moving the coreXY mechanism. And that is the stepper motor for the extruder. The extruder stepper motor is 51-52 degrees Celsius. In my next test I want to measure the average printing speed. I have this object with base length of 200 mm, this means the perimeter is 800 mm, and I want to measure the time of one circle or several circles and calculate the average speed. I had one failed print, but I pre-leveled the bed when everything was preheated, and I also used some printer fix for better adhesion. According to my calculation, the average printing speed for this object was 200 mm per second, but it was set to 250. And this is because the first few centimeters of that line is used for accelerating before it reaches the top speed. Printing is finished in 8 minutes and 45 seconds. And one interesting data, if this would be printed on my Prusa Mark CS using 0.2 mm speed profile, the printing time would be 42 minutes. Of course, here the speed is reduced because the perimeter it tried to print nicer, so it slows down, but with these different parameters this would be the printing time. And a final thought about Ender 7 3D printer. It's fast, but don't expect, 5 times bigger speed. According to my experience, for average objects you can get maybe double the speed or half of the printing time. Space for improvements, well, it would be good to have an enclosure and higher printing temperatures, but beside that I really hate this frame, so it really covers the view, not only for camera but for eyes too. So don't be surprised when next time if you will see this printer in my future videos, you will see some kind of holes here. I don't recommend to cut it completely because I believe that this rigidity, this frame has to be closed because there are some idlers supporting the timing belt, so don't cut it, but I will see. I had some problems with this carborundum glass. For smaller objects like Benchy or this rabbit, it was fine, but when I tried to print this bigger object, I had some problems with adhesion. I had to use some adhesive material, probably a hairspray will do the same. That's why I prefer the PI sheet. This touchscreen is great, so it's very sensitive like a smartphone, but the user interface is a little bit too simple for my taste. I understand this is also recommended as a first printer for beginners and they didn't want to confuse those users with some advanced functions, but it would be good to have somewhere in the menu the button where I can enable those advanced functions, and then I can set the e-steps or similar. The assembling is very simple, much simpler compared to the Sermon D1, Ender 3, Ender 5 and similar printers. Now in user manual they mentioned that this linear race has to be maintained every maybe half years to check the lubricants or similar, so not a big deal. But they don't mention the timing belt. It is very important part of coreXY printer. And I believe at least once a year that tension on the timing belt has to be checked. Now there are some instructions how to remove this frame, and probably in that case then it will be visible where can I adjust the tension of the belt if necessary, but that's the subject for the future. Well, it would be good to have VL touch with this printer. I saw in user manual on mainboard there is a space for BL touch. Mechanically, I'm not sure where could I mount on this head, but it will really help, because if it is also advised to be as a first printer, so I did that mistake that I leveled the bed when it was cooled and I had a fair print, so I had to level it when it was preheated. With BL touch we wouldn't have this problem, because it always touched the top of the surface and create an offset mesh, and then that leveling it would be perfect. If you have some additional experience with this printer, please write me in a comment. Thank you for watching and happy printing!